Okay, let's get started. The biggest highlight, I guess, is we have 3 new maintainers. It was also published on the GitHub discussions. We have Jingren from ByteDance, and Beinan from Uber, and Wyatt from LanceDB, who have been voted into the maintainers. So thanks for the contributions. And there's a bunch of new PRs that were merged past 2 weeks. And also we published a blog about geospatial support. So that's also a work with lots of help from many different people. So for people who are interested, please take a look at the blog. Oh yeah, we also added a bunch of skills. So people can install the skills. I guess we can jump to the release. Yeah. Yeah, there are too many highlights. For this, well, do you want to discuss that?
Sure. I just created RC2, so I'll be testing that. I think from RC1, we wanted to bring in some important fixes, and also like we just at the same time had a DataFusion upgrade, and so I wanted to get that in. So hopefully that should be good. We'll be verifying that release today. I will say the versioning has gotten a little bit wonky because now we're at the 4.0 beta, and I think that's because after we created the 3.0 release branch, we did like merge the DataFusion upgrade into main and then backported it to 3.0. So even though both the 3.0 branch and main both have that change, it's like sort of represented as a breaking change between them. Probably not a huge deal, but it's a little bit unfortunate. Cool. Yeah, I'll post sort of broadcast once I have that verified from our end, and other people can verify it as well.
Sounds good. Anything else we want to discuss regarding release? Okay, then let's jump to the discussions. Well, I guess the first one is posted by me. So just want to share here. Actually, let me switch the screen. So for the past few weeks, I did quite a few benchmarking for the commit performance. Well, just commit and load manifest performance for Lance, and just trying to see at what point it's going to break. And what I did is essentially I keep doing the sequential commit and load without any caching, of course, just to see the raw performance. And I did up to 20K commits, which is typically more than people usually have. So it should be a good representative. And I can probably go through the result here and talk about the next steps. One part of the setup is I test a few different combinations. The first one, the most important thing I did is I did the optimization that I think me and Will discussed, that we can add a hint file, essentially similar to Delta Lake, but in addition to what Delta Lake has, what we do is we do 2 things in parallel. The first thing is we do the normal listing. The second thing is we read the hint file and we try to see if there are new versions on top of the hint file by doing head operations. So we do these 2 work streams in parallel to figure out what is the latest version. And whatever wins first will return the result first. And at the commit time, we just commit an additional hint file indicating that the table is at this latest version, but that file might get out of sync or it might not be written. So we still have the listing as a backup resolution. So for the hint file, what I did is I tested the traditional way, which is you just write a JSON file saying the version as some version. And there's another interesting thing I tested, which is I can write a file with the file size equal to the actual version. And the benefit of that is you can just do a head operation to know the file size, and that file size is exactly the version number. The problem of that is probably if you get a lot of versions, then the file is going to be pretty big. But for the number of commits, it's typically okay. So I just played around with that, and this sync and async here, it just means that when I write the hint file, do I write that and wait for that to complete, or do I just file and forget? So that doesn't interfere with the main performance. And no hint is the baseline for without all these optimizations, what will we get? So I tested on both S3 Express and S3 Standard. The result is that I guess I had a summary of the results. Okay. Yeah, I guess we can look at the S3 Express first. That Express is massively improved with this optimization. That essentially, when we didn't have the optimization, because S3 listing is not ordered, we have to list all the manifests, which means that the more manifests you have, the longer it takes. So this one essentially cut down the performance to much better. For S3 Standard, there are some improvement for loading the manifest, like something around 40 milliseconds. But it's actually not as bad as I expected, even without the optimization. I was expecting it to go very linearly, but it's actually staying mostly just a very flat slope for the increase. So in general, S3 Standard is actually pretty okay, even without the optimization. But the optimization did bring down the load performance. Well, I mean improve the load performance. And for the JSON, this is just Express versus Standard. And for the two formats, the file size one, we did see some improvements in general, that it shows lower latency. But I'm a bit undecided right now, like because the improvement is not that much. There's like 8 millisecond improvement, 6 milliseconds. So I think this part is what I want a bit more feedback on what we do here. Do we just go with the standard, or do we think this optimization is worth it? And for the sync versus async, this is just trying to see how long it takes to commit the additional hint file, and is that going to have a lot of impact? Seems like there's, I think the difference is something like, where is that? Something like 10 milliseconds, roughly, in both cases. Yeah, 10 milliseconds to write the additional hint file. Yes. Yeah, that's something I like to just share and see what people think.
Yeah, I think I agree that I think like writing the JSON file makes a lot of sense. I think I agree that the file size doesn't seem to be worth the complexity. There was a moment where I wondered if there was some other metadata field you can fill in when you write objects to object stores, but I think it might not be worth pursuing that. I think the most straightforward and most compatible thing is just to write data to a file that you can read really quickly.
Yeah, I think the problem with using any metadata file for object storage is just it doesn't work with local file system. So yeah, and I think I'm also leaning towards just do the JSON thing, and that seems to be good enough.
How does the like the okay, never mind. I think I sort of have an idea of how it works. I was gonna say how do we know, because like the hint files, you like use the hint and then you call head sequentially or in parallel until you find the latest one? Or
currently I just call it sequentially, but I think this is something probably missing in this test because I always do commit and log, command log. So it doesn't really have any additional, like the hint never goes out of sync, essentially. So it essentially just read the hint and then do a single head that never sees any new versions. Yeah, that's something maybe I also want to test, which is when there's high contention, what's going to happen. Yeah.
Yeah, I think that's worth testing just to make sure that it works correctly. I think if you bound it so that you do the list and like the sequential head approach in parallel, and then just take whichever one gets there first, I think that's always going to get you within a bounded amount of time, and that works.
Yeah. And one other thing I also wanted a protocol test is just Azure Blob Storage. I think there's equivalent premium versus non-premium storage. And we should probably make sure that also works efficiently on this. Yeah.
If I remember correctly, there's a storage class in Azure that makes listing a lot faster. It's a premium. I think it's a feature.
Wait, are you saying it's not premium? It's like another flag?
Sorry, one of the storage classes gives you better listing performance. It is a premium feature. You got to pay more.
Okay.
In Azure, yeah.
Okay, I probably need to look more into that. Okay. So that's it. I guess I already have the PR out, and I will probably this probably requires a vote for the spec change, since it's touching the transaction, and I will start to organize that.
Yeah, the spec change is like adding that hint file, basically.
Yeah.
Okay.
You think there's a cost angle to this as well with lists versus gets?
Yeah, it's definitely a bit more expensive. You're doing more requests.
Yeah, because I remember the Amazon storage team came back with a solution that balances lists and gets pretty much, also taking into account like how much it costs. And I remember the only takeaway was I had from that was it was not intuitive. It was not what you thought was cheaper or was better. They went with a cheaper solution. Anyways, that was just a conversation I had before. Probably it's not applicable here. So,
to be honest, I don't know the price of listing and head.
it's like basically free, right?
Okay, so yeah, this is actually also I wrote that for the caching for multi-tenant use case. This is an issue I don't have a design. It's just an issue I like to discuss with the group here. That recently I'm implementing caching for both the Spark connector and the Trino connector. And also internally, I think for LanceDB, there's the internal engine that also does some caching. And the main component that is doing caching now is basically the session that has the index cache and the metadata cache. And the general strategy seems to be basically the one I implemented in both Spark and Trino is just for a single tenant use case, you share the session. So you always use the same session, and then every time you open a data set, you passing the same session object into that, and that essentially gives you caching throughout the even across different executions of different queries. But it doesn't really work for multi-tenant case. I think for Spark, it's by default single tenant. Like there's the assumption of single tenancy for Spark because you configure all the permissions in the connector. But in Trino case, every query comes with an identity, and then the identity can impact how you access the object storage. like you can imagine, for example, there is a JW like OAuth token with the identity, and then that OAuth token is used to exchange some access credentials to your storage, and then that makes the caching a bit complicated because because today the session contains both the cache and also the object store registry, and that means you have to have the object store initialized and kind of bonded together with the cache. That means every tenant essentially needs to have a different session so that they are not interfering with each other. But that also brings a lot of overhead because if they are accessing the same table, then the same content has to be cached like n times if there are n tenants accessing that. So just curious what people think here. Is that something we should extend in Lens, or is that more like an enterprise feature? I think I'm actually not sure about this at all. So just wanted to see what people think.
Yeah, I'm curious. I think it's already intended to be, at least the object store cache is intended to be like different per like different credentials. So like it's the object store cache is keyed by the object store parameters. Okay. It's like right there. And so I would think that if you have different object store parameters, whether they be credentials or which bucket you're pointing to and so on, that they would give you different object stores and keep that separate. Was that the issue, or is it something else?
I think that's probably the main issue, because what I see, then that might be a bug then, because what I observe is that before I do the separated session, there's cross contamination essentially for what one user is able to was using another user's cache, and then there are some access issues across it. So yeah, sorry, please continue.
The one other thing that I might suspect is that the it's not that part of the cache, but then there's I'm trying to think. In the metadata and index cache, the actual index objects and in some of the metadata objects, I think actually mostly the index objects, I would think, might hold references to file readers that hold an object store reference. And so it could be that the object store cache itself is like separate, that when they like are requesting like a cached index that's not really keyed by anything, and they'll get the cached index data, but part of the cache index struct is a reference to an object store, which will just be whoever opens that object, that index part first. And then it might try to read like an index subpartition with the wrong credentials. Or expired credentials, maybe.
Oh, I think there's another problem, which is, I don't know if that's handled. So suppose, let's say I, like Jack access this table A, and some files got cached, and then another person comes and like with a different object store, but it's accessing the same table. Does that mean it will bypass the object store for reading? And then if that person doesn't have access to the actual files, it will actually be able to read the cache. Would that ever happen?
Sorry, say that one more time.
So if I access the table first, and then the metadata files got cached, and then someone else comes with a different object store, but it's trying to access the same table, does that mean that the person can essentially bypass all the object store access and then directly get the information from the cache?
Yeah, I would think so, because there's no permissioning on top of it.
Yeah, that might be a problem because that essentially bypasses the access check.
You're
Go
talking about this in terms of Trino using like a session level cache, right, Jack?
Right, right.
Okay.
Yeah, that might be something we have to think of as a part of this. But overall, I think the problem I saw was like just one person using another person's object store. That seems to be a bug. I can look into it. Yeah.
Yeah, I do think one thing we should do is figure out if there's any object stores that are implicitly cached in the index cache and metadata cache, and see if we can pull those out.
I think some of the indexes hold on to readers, which have an object store pointer. So that seems very likely, like the bitmap and the inverted, maybe B-tree as well.
Yeah, those need to be at some point refactored somewhat anyways to make sure that they aren't using a lot of shared references. So might be worth rethinking that, how the index cache works. Yeah, I think that's the one source of the issue, and I think you're right, Jack, that I think the index metadata cache might be an issue if you're relying upon object storage to enforce permissioning. And I think at some level, I'm not sure if that's, unless we build in some sort of permissioning thing into the metadata, and that might be somewhat unavoidable.
Yeah.
It might be more like the namespace level needs to be the one enforcing permissions to like what tables you have access to. We don't have like a notion of like permissions like in Lance that's enforced, but maybe we might at some point want to. At the very least, you can enforce whether or not you can open the table at the namespace level, and then that'll sort of dictate your read permission. And you can enforce, I think, still at the object store level, you can still enforce whether or not you can write via the object store permissions. So yeah.
Okay.
I mean, if you really want, you can just read the first byte from the object store just to see if you can read it.
No.
Yeah.
Yeah, I actually was thinking about that, but we'll have to see how that works. Yeah.
Yeah, I think like cache invalidation here gets super hairy with permissions.
Cool. Any further comments before we move to the next? Okay, then the table. I guess, Kevin, do you want to discuss that?
Yeah. So I've been out and just got back. So I just saw there's a lot of discussion around metadata table, which is super exciting. I think the general concept probably resonates with a lot of folks. Is there anyone else here who was on that thread?
Which one's metadata table?
Let me put this in the chat. It's exposing the metadata, structured metadata as a data table. You know, as a data frame, as a table construct.
Yeah. Okay, now I remember. Yeah.
Yep.
Actually, I have a PR for one of those somewhere.
Yeah, I did some research after we discussed last time. I was looking into the prototype and proto buff, and looking into how to like auto generate the schema from protobuf. But that's to the extent of how much I've worked on this. But yeah, I'll take some extra time and take another look. I think a couple of folks have already started some of the work.
Okay. Yeah.
Yeah, Jack.
There's a comment I think from Weston. I think I didn't fully understand, because we are saying if the lens metadata is a table, they need some kind of storage. Are we suggesting we are kind of materializing the metadata tables, or did I misunderstand?
I guess I just figure if we make it available as a table, people are going to do a select star on it. And maybe we should say that's like, if there's a lot of versions, that would grind to a halt.
Yeah. Should we call them views instead? Does that help?
Even if it's a view, like it,
Materialized views.
I guess what I'm thinking is without some kind of metadata cache, like it's been discussed in some of the other discussions, then making this a table is going to invite people to start doing, like we added a list indices functions, and then people complain because it's too slow. If you add a metadata table and you can't do select star on it quickly, people are going to complain because it's too slow.
Yeah, I mean, that's fair. I have a good example right now where I'm adding ones that list all the tracked files for all the different versions and all the different just total files under the base URIs, and that's going to be slow to query.
Yeah.
But
Well,
my intended use case is that like you'll query it and you'll save it into some sort of materialized table, and then you can query it faster.
And also, does making a table mean like it has a table provider? And if it's not backed by an actual Lance table, we'd have to make a new table provider and that kind of stuff. It's all very doable. I think it's nice to consume. I just a warning that it may be more than just like picking what fields we want to be columns and how we map those things. Like we should think about how this table is going to actually perform too.
Yeah,
because I think the metadata tables in Postgres or something like that, I'm pretty sure they're actual tables. Like they're not simulated views.
Yeah, that makes sense. I think initially it was more of a how do we expose this so it's easier to access and to use, but whoever starts to use it, the first thing you'll notice is, hey, I'm doing a scan of all my metadata. That becomes really slow. So I don't know how you would solve this. Like, I don't know if there's a way to cache and checkpoint and do all of that, but that's an interesting idea too.
Yeah, and then I think the manifest store discussion I had is probably not. I was thinking this is also related to manifest stores because I wasn't sure at the time which direction manifest stores were going. If we go like the latest suggestion that you had, Jack, was manifest stores will always have an object store. Like object store is still going to be the ground truth. So that means if you want to turn your versions into a table, you could do that without involving the manifest store. But like the manifest store does have a list versions method potentially, Like, it's still under discussion whether it would have that or not. And if it did, then, does the manifest store get involved in creating this table as well? I don't know.
Yeah, for list versions, my current understanding is essentially we treat that as the manifest list versions might give you additional entries comparing to if you do that directly against storage, because storage might have some intermediate staging manifests that will essentially just ignore if you just goes through storage. And then if the metadata table is, I guess from an implementation perspective, we can still yeah, that becomes essentially kind of like view and materialized view. Like the materialized view might get out of date. That's kind of how I feel, how I think about that.
Yeah, and there's some. I think there's some more into that, just because a lot of the metadata is pegged to a specific version, right? So it is like kind of in a way immutable and reusable. So like we can just materialize it as an option, and then the next call, even if it's let's say like we can use it to build the next call incrementally even, right? So that's one advantage of like doing something that is pegged to a version. But yeah, I think like these are all, I think, like great optimizations. I think the first cut at least is just to make sure we're exposing the concept with a giant red button that says, hey, this is going to be slow.
And I actually like how well implemented the hacked files and all files that we don't even need I think we don't even need like official concept of the tables. It's like as long as we expose the functions and return arrow, then that's technically already a metadata table, right? And
right. Yeah, you just need a schema and fill it out.
We define the schema
yeah.
in the function.
Yeah, I mean, you call it a function, I call it a table provider, it's the same thing, right? But yeah, I guess on that, all files is a little bit interesting. Speaking of not scaling, that's definitely not going to scale. to crawl your object store is a lot of work.
Yeah, I mean that's part of it's something we have to do for cleanup anyway, so we can make that faster. But
yeah. Again,
it's just like being able to query untracked files.
Yeah, it's like, well, we have no better solution yet, so we have to do it this way.
Yeah, but I agree. I think a first good pass is just being able to get this out as like an arrow, get various pieces of metadata out as an arrow stream, and then from there you can. I think what makes you go from an arrow stream to like an actual table provider is being able to push down filters. So for example, like in tracked files, for example, you could push down a version, just be like, hey, give me all the files for version 42. Like that would be possible, or even pushing down projections. If you're like, hey, I just care about, I just care about the paths of all the transaction files for versions 45 to 260. But I think a good first pass is just give me everything, because that just makes it so much easier to query and analyze information about Lance data sets.
Yeah. And I think what we were discussing about, like, oh, you can just materialize it separately on your engine. I think, that could be like a tip that says, hey, if you don't want to do this and go to your object store every time, run it as a temporary table, or like save it somewhere, right? I think that's a nice tip.
Yeah, that's how I intended upon using this, is just like taking it, writing it out to some Lance files, and then querying it with .db. Yeah.
And then if we're spitballing optimizations here, I think for all files, S3 at least has a S3 inventories table. It's not the most up to date, but it gives you a table view of your bucket. So
I haven't heard of that.
you have to, I think you have to enable it, but they basically take care of telling you what's in there. So instead of crawling it, you just like get a view. It might be outdated, but I think for like cleanup operations where you're like running it periodically and just like getting rid of some stuff, I think that's a great trade. That's a great trade-off, and it's a lot cheaper. Again, very much like in the weeds of optimization.
Does other storage have something similar?
They should. I think everyone, at least from what I've seen, all the clouds are moving towards kind of exposing their own like internal stats as like tables, right? Like I think S3 started that with like the inventory table, with S3 metadata, right, as a table. From what I've heard, it's on the roadmap for the other object stores. Yeah, I'll spend some more cycle to look at this. I think it's super interesting. I'll put some updates on the discussion.
Sounds good.
Cool. I think that's the end. Any other topic?
Oh, I have a question if no one else has anything else. For the repos and land, do you guys have a agents.md or like something similar?
Yep. I think at least in the Lance repo.
Yeah. Like whoever created it, what was the process to understand what to put in there?
I mean, some of it's probably was just put in there using like the default suggestion, but then after that, I think it was just like figuring out iteratively what the agents needed to know to do certain things. So just like noticing what they're getting wrong and what is missing information. You can even like at the end of the session ask an agent, hey, like what is important information that should be in here? That would have been helpful to know. Some of this we might move over to specific skills. So for example, I a while ago added a bunch of commands and examples and even a special script for how to query code coverage and figure out which lines are still uncovered. Stuff, but I might move that to a specific like measuring code coverage skill.
Gotcha. Maybe I'll just copy this. I think this is a good, you guys have a lot of stuff in here. I think this is a good first step. Yeah, I think where you're saying that after every session, just asking, I think that's a good idea. Because I have seen things that I keep on telling the agent over and over. So, cool, thanks.
Okay, I guess that's it. Thanks, everyone.
Thank you. Bye.
Thanks. See you.